Consider the four given graphs that are indicated on these grid lines, and with various points there, A, B, C, D, E, F and G coordinates are given there. So I want to know what is the missing detail here to fill in the missing detail. So if I look at the green graph here, the green graph is L1, line 1, and we see that the points A, -3,3, and B, 0,3 lies on that line. So to find the slope, M1 there, I will just have to use my formula, change in Y. So it is 3 minus 3 divided by 0 minus 3. If I compute that, I get 6 over 3, so I have positive slope of 2. And it corresponds with what we see here on the graph. If we count the blocks, we see that to walk from A to B, we can walk 3 up to there and another 3, so it's 6 in the positive vertical direction and another 3 in the horizontal direction, so it's 6 divided by 3, corresponding to what we did there with the formula. If we look at the blue graph, we have various points here. Let us use the ones with the easiest computation. So let us take, in this case already given the value of M2, but you can also here fill in see how we work it out. I will use D and C, that will be the easiest computation. So I will have 0 minus 3, or let us say 3 minus 0. So we start with point C. So it's minus 3 minus 0, and then it will be 0 minus 1.5. 0 minus 1.5. So that means we will have minus divided by minus, and the answer will be 2 as we've seen before. Our C value or the y-intercept, and that will be the y value minus 3. If you look at the red graph, we see that M3 is the slope of the red graph, and we have 1, 2, 3 points here. Let us use point B and E. So if I take the y value of point B, then I get 3 minus the y value of point E, which is minus 6, divided by 0 minus 3. So we have 9 divided by minus 3, that gives us minus 3. So the slope of the red graph is minus 3, and we can validate that if I start here on the x-axis and then I need to walk 1, 2, 3 in the positive direction and 1 unit left to get to point B. So it's plus 3 divided by minus 1, and that gives me minus 3. That is the slope of the red graph. The C value is just the intercept on the y-axis, so in this case the C is 3. If I look at the graph, the orange graph, this is the one here, and I want to find M4, I would rather pick A and E. Slope of the orange line, which is M4, and that we get by taking minus 3 minus 6 divided by minus 3 minus 3. So that will give me plus 3 divided by minus 6, and that will give me negative a half. So we've seen now that M4 is equal to negative a half. Let me just tidy it up a little bit here. So M4 is minus a half. And if we go to our graph and we zoom in a little bit, then we can see C is approximately negative 4.5. If we now look at the statements here, we will look at a theory about the slope of lines. L1 is the green one, so this is L1. L2, the orange is L4, and the red is L3. So L1 is definitely parallel to L2. Yes, it is true, because M1 is equal to M2 is equal to 2. L1 is parallel to L3. No, that is false, because M1 is unequal to M3. And L1 perpendicular on L3, that is also false, because M1 times M3, M1 is 2 and M3 is minus 3, so that is most definitely not equal to negative 1. But for L1, which is 2, and L4, we have 2 times M4 is minus a half, and that will give me negative 1. If we look at line 1, which is the green graph, and line 2, which is the blue graph, we know that M1 is equal to M2, so L1 is parallel to L2, so they will never intersect, or nowhere. They are parallel to each other, and they have different C values. If we look at the green graph and the red graph is L3. We see they intercept there at the point B. So the point B, which is 0, 3, is where they intercept. And the blue graph and the orange graph, we see they intersect here at G, minus 0,6, minus 4.2. This is where they intercept. For the distances here, I would rather look at this triangle ABE. So we want to work out the distance AB and BE and AE. So just change that to that, and then we see that we need the distance formula. I'm just going to move this a little bit up so that we have space to work it out. We will still be able to see the coordinates of A and B. So let us find the distance AB. According to our distance formula that we do in analytic geometry, AB will be the change in the x values. So it is 0 minus 3 square plus 3 minus 3 square. So that will give me 3 square plus 6 square in the square root, and that will 9 plus 36, that is square root of 45. If I look at BE, according to the distance formula, BE will be 0. Let us take 3 minus 0, and then we have minus 6 minus 3. I have to add it, so we will get square root of 3 square plus 9 square. That is 81 plus 9, which gives us square root of 90. And then the next one, which is AE, you can still see the coordinates there. That can be 3 minus 3 square plus minus 6 minus 3. When we work out AE, then that last part there, minus 6 minus 3, becomes 3 square The answer is still 45. So on our diagram, we see that BE looks like it's the longest side, and not even on the diagram. Also here, when we compute it, we see BE is the longest one. So what we want to determine is then whether what is the value of AB squared plus AE squared. That is 45 squared plus 45 squared, and that is 45 plus 45, which is equal to 90. And if I look at BE, and I square that, I get square root of 90 squared, so that is also 90. Therefore, AB squared plus AE squared is equal to BE squared. Therefore, Pythagoras can be applied here. Therefore, the angle at A, this angle here, be 90 degrees because it's opposite the longer side. We did see in the previous example also that the orange line and the green line are perpendicular on each other. That was another way to determine that that angle is 90 degrees. Square root of that